I guess it didn't work or something. All right, we are going to do a scale change for a quadratic function today. Actually, a bunch of them. We already did this in Unit 4 for linear functions. And remember that we can think of a scale change as a transformation of a transformation, like layers of transformations. Okay, for example, here we have the function f of x equals 2x squared. This one already has a transformation on it. It's not the parent, which is just f of x equals x squared, right? Y equals x squared. This one already has an a value of 2, which means a vertical what? Stretch by a factor of 2. So this one already has a vertical stretch by a factor of 2 if we were to compare it to the parent function. However, we can still perform transformations on it. Okay, it's already been transformed, it's already been stretched, but we can do a scale change and do some transformations on it. So here we have 4 different transformations that we're going to perform on our already vertically stretched function f of x. Everybody okay with that? All right. So the first one says we're going to do what to f of x? What does the negative in front of f of x do? Yeah, it's going to reflect it in the x-axis. Okay? So let's take f of x, the expression that is equal to f of x, and plug it in wherever we see f of x. And we get y equals the opposite of 2x squared, which is just y equals negative 2x squared. Okay, you can see that I've already got f of x graphed here. It's going from its vertex, right 1 up 2, left 1 up 2, because it's been stretched, right? Okay, now we're going to reflect that in the x-axis. So instead of going up 2, we're going to go down 2. So the parent pattern goes, let me write it, 1, 1, 2, 4. So this pattern is going to be 1, negative 2, 2. What's 4 times negative 2? Negative 8. Okay. Down 8 would be off of my page, but you can, my graph, but you can see where it should be, right? Okay, now we are going to identify the effect of the scale change on our function. So we just reflected f of x in the x-axis. It was already vertically stretched. We reflected it in the x-axis. Now it has a reflection in the x-axis and a vertical stretch by 2. Questions? Okay. What does the next one say? 1/2 f of x. Anyone have any thoughts about what this might do? If we multiply it by 1/2, it's going to widen it. Okay. If it's stretched by 2 and then we compress it by 1/2, don't those kind of cancel each other out? Yeah. We should end up with the parent function by the end of this. Okay. So that'll be y equals 1/2 times 2x squared. Gives me y equals 1/2 of 2 is just 1. So it just gives me y equals x squared.
So the exponent goes inside the parentheses every time?
Well, I'm multiplying all of f of x by 1/2. So I'm multiplying that entire factor, that entire expression by 1/2. Okay, so instead of going up 2, am I going down? Is it negative? So my regular, oh my gosh, what did I do? It's fine. Okay, so this one is being stretched by 2, but now I'm going to go back to the regular parent pattern, which is 1, 1, 1, 2, 4, right? Right? So it's going to get wider. The compression is going to undo the stretch that we already had. So we have vertically compressed. Yes, we have to say it. F of x by 1/2 to get the parent. So we can do transformations of transformations, and sometimes those transformations undo each other. When you get to algebra 2, you're going to learn that those are called inverse functions. All right. What do you think this next one is going to do? Stretch it more. So it's already stretched by 2. If I stretch it by 3, the total stretch is going to be by 6. Okay. So y equals 3 times 2x squared. That gives us y equals 6x squared. So my pattern is going to be 1 what? 6. Okay, and then I'm going to multiply the 4 by 6 also, and I'll get like 24, which is obviously not going to fit on my graph. Huh? Because 4, we're multiplying these by 6, right? So left one up 6, right one up 6. Look at how narrow that one got. Okay, so this was a vertical stretch of f of x. It was already stretched. We stretched it some more. So we only stretched f of x by 3, by a factor of 3. But if we were comparing this to the parent, it would be stretched by a factor of 6. Everybody okay with that? All right, what do you think the last one is going to do?
Reflect it and make it narrower, maybe?
Okay, look at where this is. Do you see it's in the K spot?
Mm-hmm. Oh, so it's going to go down.
Yeah, it's going to shift down by 5. Okay. So we're going to say y equals 2x squared minus 5. Okay, so every point on here is going to get shifted down 5 units. So I'm going to shift my vertex down 5. I'm going to shift this point and this point down 5. And then I don't really have any more pretty points, so I'm just going to kind of wing it.
What about the 6? Is the 6 up there now a point?
No, that's not a point because it should go left 2 up 8. It doesn't hit until here. In here. See, it's not touching at 6
Oh, that's what I did.
if you think about the pattern. But we can shift that 8 down 5. If I do 8 minus 5, it should be at 3. Okay, so we shifted f of x down 5 units. So it's still vertically stretched by a factor of 2, and now it's also shifted down 5 units compared to the parent. Questions for me? Okay, that was the warm-up round. Now it's time for leveling up. All right, we have to use the function f of x equals 3x squared to perform the scale change described below. So, I already have a stretch by a factor of 3, okay? So looking at this, I'm going to do a whole bunch of stuff to it. What does the negative do? Reflect it in the x-axis. What does the 1/3 do?
Narrow.
Wider. Okay, so it was stretched, but I'm going to widen it back up again a little bit. And what does the +7 do?
Up, make it forward.
Okay, what's the math word for going up?
Shifting.
Shifting up. So I'm going to do 3 different things at once. Hold on to your hats. So I'm going to do y equals negative 1/3 times 3x squared, and then add my 7. Now I'm going to have a little bit of simplifying to do. Okay, if I have a negative times a positive, what's that going to give me? A negative. So I can already write down a negative. Now I can deal with the magnitude. What is 1/3 of 3? 1. So I have negative 1x squared plus 7. Okay? Now I have to graph my equation from part A. So what is my A value? My A is negative 1, so I'm going to open down. Okay, my H is, I can't really see it, so it's 0. And my axis of symmetry is x equals 0, right? Okay, my K is 7. And I'm going to use my pattern. 1, 1, 2, 4, 3, 9. But my ups, I'm going to multiply by negative 1. Okay, so vertex at 0, 7. My pattern says that from my vertex, if I go left or right 1, I go down 1. If I go left or right 2, I go down 4. That was too many. If I go left or right 3, I'm going to go down 9. 7 minus 9 is negative 2. Whoops, I missed. Okay, questions for me?
Nope.
Fun little review of graphing in there. All right, I have a different one. This time they're giving me a graph of f of x, and we have to write its equation. Okay, so what 3 things do I need to write an equation?
H, and
Yep, A, H, and K. I translated it into alphabetical order.
That's it.
All right, so to find our a value, we have to look at our pattern. We start at the vertex. From the vertex, if we go left or right 1, we go up how much? 1. If we go left or right 2, we go up how much? Okay? This should look very familiar.
That's a movie.
It's the normal one, so what do I know my a value is? Correct. Sometimes the math gods smile on us. Okay, what about the h? 0. And the k is 1. All right. So, f of x equals,
Oh, wait, do I write it in vertex?
yep, vertex form. Okay, if the a is 1, do we have to write it? No. Okay, if my h is 0, do I have to write it? No. So x squared plus 1. Well, if you do the long version, fine, that's fine, but then you should simplify it to this. Because we're going to plug it in, and the more complicated you make it, then the more your head is going to hurt. You want it to be nice and easy for when we have to plug it in. All right, now we're ready to perform the scale change. So when I look at this, I see that my f of x is only shifted up 1, right? That's its only transformation. But now I'm going to do some more transformations to it. I'm going to vertically stretch it by 2 and then shift it, what?
Down.
Yeah. Okay, here goes nothing. Y equals 2 times all of f of x minus 5. What is f of x? X squared plus 1. So I have to plug in the whole thing, put it in parentheses. That way I know I have to multiply the whole thing by 2. I can't pick and choose. I'm multiplying all of x by 2. All right, how do we get rid of those parentheses?
Multiply by 2.
Distribute. Okay, so I've got y equals 2x squared plus 2 minus 5. See anything that looks combinable? The 2 and the negative 5, that gives me y equals 2x squared minus 3. Do I have to graph that one? Does it say?
Oh, no.
No, so you got to read the directions because sometimes you're going to, on all the scale change problems, you're going to have to do the scale change, okay? But some of them you'll have to write the equation, and others like we did on the front, you'll have to graph it. So you just have to pay attention, otherwise you're going to be confused. All right, let's try another one. All right, what 3 things do we need for an equation? A, H, and K. All right, let's find the A value. This one from the vertex is going right or left 1 up how much? Is it going up all the way, a whole one? A half. And if I go right or left 2, I'm going up how much? 2. So instead of being 1 and 4, it's half and 2. So what am I multiplying by? A half. Do I need to write the original parent A value table pattern? It goes 1, 2, 1, 4. So in order to go from 1 to a half and from 4 to 2, I know that my A value has to be 1/2. It has to be. It doesn't go up all the way. A is 1/2. What's my H? 0. And my K is -2, correct. All right, let's write this equation. F of x equals 1 half. If my h is 0, do I have to write it? I do not. Good. And what about my k? -2. All right. Now we have to plug that whole thing into my scale change rule. Here goes nothing. Y equals -2 times the whole thing, f of x, plus 3. Okay, f of x already has a vertical compression by 1 half. It's already shifted down 2. We're going to do a whole bunch of stuff to it. We're going to reflect it in the x-axis with that negative. We're going to vertically stretch it by 2. We're going to shift it up 3 units. Ready? All right, plug it in. How do I get rid of those parentheses? Distribute. Pew, pew. That gives me y equals. Okay, I know if I do negative times positive, I get a negative. What's 2 times a half? 1. Okay, now I've got a -2 times a -2. Positive 4. Bring down the plus 3. Combine my like terms. Yep. Plus 7. Y equals -x² plus 7. Do I have to graph it? Nope. But I could. Didn't we already graph that one? Yeah, we already graphed that one. Turned out the same as this one. Isn't that funny? All right. All right, here's another one where we don't have to write the equation, but we do have to graph it. Okay, so we're going to perform the scale change. We already have a vertical stretch by a factor of 4. Okay, we're going to do transformations on our transformations. What does the negative do? Correct. Reflected over the x-axis. What does the 1 half do? Vertically. Is it a stretch if it's 1 half?
Oh, no.
Okay. It's going to compress it by a factor of 1 half vertically. What about the little plus 2 on the end? Huh? Shifting up 2. Okay, here we go. Y equals -1 half times 4x squared, close parentheses, plus 2. Okay, this time we still have to multiply, but do we have to distribute if we only have one term in our parentheses? No, we don't have to distribute, we just multiply. Okay? So we're multiplying the -1 half with the 4. So negative times a positive gives us negative, and then a half of 4 is 2, so I get -2. You can treat those two separately. You can take care of the sign first, and then deal with the magnitude of your product after. It's really helpful when you're doing mental math to break it up into pieces like that. All right, bring down the x squared and the plus 2. All right, now to graph, we need the a, h, and k. What is our a? -2, the h, 0, the k, 2. So I'm going to put my vertex at 0, 2. Then I need to do my graphing pattern. 1, 1, 2, 4, 3, 9. What does my a value say to do to all of my ups? Multiply them by -2. Good. So I'm going to go down 2, down 8, down 18. I'm not going to have room for that one, I bet. 2 minus 8 is negative 6.
Oh.
Okay, we're coming down the home stretch. Is this our last one?
Mm-hmm. All right.
Okay, we're looking for which one is true. If I transform f of x equals x squared plus 9 into the graph of g of x equals 3x squared plus 9, which is true? Wouldn't it be really nice if I had pictures of these? Okay, so where can I get a couple of pictures with very little effort?
Just in or put in the calculator.
Put in the calculator. Sounds good to me. All right, go to y equals. What is it? X squared plus 9? And 3x squared plus 9?
Mm-hmm.
I should see everybody typing this in. Okay, I'm going to go to my graph. Well, I can't really see what's going on. How can I change my window so that I can see more of that graph? No. If I want to change my window, I can go to window. Okay, and I want to see higher y values. So am I going to change my y min or max? Correct. What do you think? 20? 20 should be good. Go back to my graph. There we go. Okay, so my blue one is x squared plus 9. My red one is 3x squared plus 9. Did the vertex move?
No.
No. Did I reflect at all?
No.
What happened when I went from blue to red?
I got
How do you mean
Narrower
smaller?
stretch.
Narrower, so is that
Narrower
a stretch or a
stretch.
compression vertically?
vertical stretch.
Vertical stretch. So I vertically stretched it by 3. Okay, let's pick which one is the true one. Go ahead. Check it with your neighbor. Okay, remember that zeros is where it crosses the x-axis. Did the number of zeros change? No, it stayed 0, right? We had 0 zeros, so it's not that one. Did the axis of symmetry shift right? Nope. Did the function get translated up 3? No, it got stretched. Okay, what about the vertex? Did it stay the same? All right, easy as pie.